Hi everyone, and welcome back to Fundamentals of Engineering with Farhan, Seismic Design. If you remember, in previous video we solved this frame with the parallel condition example. Like the problem statement is we have like three columns, 1 and 3 are identical to each other. If the forces of F, lateral force of seismic, lateral force of F is distributed evenly between these three columns, we want to know what is the height of the middle column, like column 2. So 1 and 3 are identical to each other in terms of their height, their EI, and also their support conditions, like both of them are fixed, and the middle one is fixed and pin. And the height is different. The modulus of elasticity is 2EI and the other two are EI. So if you remember, we solved it in the parallel example, like we told that if in parallel situation the force is distributed between the columns based off their stiffness. So if we know the force inside each of these columns based off the problem statement is provided with 1/3 of force, then based off their stiffness to the total stiffness, we can calculate H2 because the height is already embedded in the stiffness formula. So this time we want to solve it even with a easier approach in terms of math calculation, but it's again lies in the parallel condition of these columns. So as the lateral force applies, the frame deform as you can see here, and the top supports, all of them converge to sliding support, and then we have like this is solution 2. This is our solution 2, an easier approach. This is even easier approach for those of you who want to solve it in like less than few minutes. So again, problem statement says if the force F is equally distributed between all these three columns, so we can easily say each of forces are equal to 1/3 of the force. And in parallel condition, we know that force is directly related to the stiffness, and also in parallel condition, delta remains the same in all of them. So delta at the top here is equal to this delta is equal to this delta, and all of them are equal to the delta total. So if that's the case, we can easily jot down like delta is equal to force over stiffness. Our force is provided to be equally distributed, so each of them carries 1/3 of the force, and the stiffness is also, if the delta is the same, we can conclude that the stiffness also remains the same. If F is the same, delta is the same, so K, there is no way to but to be equal for all of them. K1 is equal to K2 is equal to K3. So in that case, it just made the problem far simpler. So it just simply says column 1 and 3 are identical to each other and their stiffness is 12 EI over H cubed, and the middle one is like 3 EI over H cubed, and instead of EI replace 2 EI, and H2 is the only unknown. We can easily know that K1, if K1 is equal to K3, you can easily calculate H2 is equal to 2H cubed is equal to 30 cubed, and then it just gives us H2 is equal to almost 24 feet. So the whole calculation for this problem was a conclusion for the parallel condition, jotting down the stiffness, and just jot down this line to get the answer. So H2 Height of the middle columns in this problem is equal to 23.8 feet or almost 24 inches. Thank you. We'll solve more problems in seismic design in next videos.